Hello, everyone. This is Professor TK, the chemist, coming to you all today to do a video on the atoms family, calculating atoms with protons, electrons, and neutrons. And this is going to be for my T7 chemistry nursing students. So if you are trying to get into the nursing program, this video is for you. This video is for you. So before we get started, let's make sure that we have all of our features set and in place. So that's what we're over here doing now. So bear with us for a moment. All right, so here we are. I'm just looking on one side to make sure that everything is working the way it should be. So I'm here with you guys. Let me make sure it is here. Okay. All right. So here is the first thing that we're going to actually discuss, and that is, there we go. What is an atom? So this is something that a lot of students have to know about on the T7 exam. And when you have to know about this information, you have to be confident in your skill sets with this particular session. Now, here's the thing that I want you guys to keep in mind, that the T7 exam will only have 8 chemistry questions on there. That's right, y'all. Only 8 chemistry questions. And while that doesn't seem like a lot of questions, it's a lot of content that you have to know. So this is one of the skills that you're going to have to be familiar with for this section. And so on your screen, you'll see the definition of an atom. So what is an atom? Well, it is the smallest unit of matter. It is composed of 3 main particles, and those particles are protons, neutrons, and electrons. And it is the central nucleus containing the protons and neutrons. And I'm actually going to dive a little deeper on those 3 key words here so that you all will know exactly what we're talking about and what we mean as it relates to the atom. So the structure of an atom consists of protons. That was one of the key words that I mentioned to you before. Protons are positively charged particles in the nucleus. Positively charged particles in the nucleus. Sometimes you will see protons written just like this, a P with a positive sign, just like that. Neutrons, on the other hand, are neutral particles in the nucleus. And again, the symbol notation for a nucleus, or excuse me, for the neutrons, is an N with a little 0. Okay, again, that just means neutral. Electrons, those are negatively charged particles in orbitals around the nucleus. So again, when you think about electrons, they are just negatively charged particles. And the symbol that you'll see is an E with a little slash mark. Oh, my poor pooch has kettle cough. Hold on, guys. I'm sorry. All right. So some other key terms you need to know are atomic number, atomic mass, and isotopes. What do we mean by those 3 words? Let's look at the first one. Atomic number means the number of protons in the nucleus. They are unique to each element. So when we look at our periodic table and we find the atomic number, that illustrates the protons and the electrons, okay? So one of the acronyms I like to tell my students is PEN. P-E-N, protons equals electrons, which also equals neutrons, PEN, P-E-N. The second key term that you need to be familiar with is atomic mass. That is equal to the total number of protons and neutrons in the nucleus. So when you look at the nucleus, okay, so let's say if I draw this out right here, in the nucleus, I'm going to have my protons and my neutrons. And on the outside, of course, are your electrons. And then finally, isotopes are atoms of the same element with different numbers of neutrons. And again, we will get into that a little more throughout this lesson. Now, I need to keep in mind or have you guys kind of analyze what this periodic table looks like, because these are the things that you will notice on your TEAS exam. They may not give you a periodic table, but they may give you a block or sections of these elements. What you need to know is that in each block, for instance, if we look at boron, which is atomic number 5, I'm going to circle that right here. That 5, the numbers in the upper left-hand corners are equal to the atomic numbers. However, the numbers that you see with decimals, those are your atomic mass numbers. Now, when we talk about the atomic mass number with relationships to protons, electrons, and neutrons, we must keep in mind that we have to round up to the nearest whole number. So if we're looking at boron and we see that there's a mass number of 10.811, we're going to round that off to 11. Carbon, 12.011, is rounded off to 12. If you look at oxygen, you see there's 15.999. Well, we'll round it off to 16. So again, when it comes to looking at your periodic table, you want to know that the number in the upper left-hand corner is called your atomic number. So again, I will make a little example of this so you all can see that here, okay? So again, we'll go back to boron. So that's the atomic number. And then, of course, the chemical symbol, okay? And then the chemical name is boron. And then the number that you see at the very bottom with the decimals, 10.811, that is the atomic mass number. Okay, now, what you need to also keep in mind that there are other numbers on this periodic table that we will dive a little deeper into later on as you work with me throughout this lesson here. You're going to find out that each of the numbers represent either a group number. They also represent the atomic number. Yes, they also represent the periods of the elements, and they also tell you the ionic charge of these elements. So there's a lot that you will see on the periodic table, but they mean different things, okay? They mean different things. We'll be referencing the periodic table throughout this course. So just keep in mind that what you see, we will be making references to them so that you don't forget the information. Now, if I were to tell you that I wanted you to calculate the atomic mass, all you have to know is this formula right here. This formula that you see on your screen says atomic mass is equal to the protons plus the neutrons. Keep that in mind. Protons plus neutrons. So if I gave you carbon 12, for instance, okay? Sometimes you'll see it with the chemical name, carbon, and then a dash 12, or you may see C12. They mean the same thing. Well, if I look at my periodic table here, and I look at the very bottom, right here, let me go ahead and move this out the way. Okay. Hold on, guys. Okay. If I notice here that the protons, I'm going to circle it here. You see this number right here, that 6? That is the protons. That's also the electrons, okay? That's also the atomic number. If I see that 6 there, that tells me that I have 3 things that I can actually write down 3 different times: protons, electrons, and atomic number. Now, if you notice here at the very bottom, 12.01, that is the atomic mass number, okay? Your mass number. All you have to do in order to establish what your protons are is to look at the atomic number, yes. But here's something else that you guys need to know. To get your neutrons, and this is a great segue so that you guys can understand this, you're going to take the atomic mass number and you're going to subtract that from your atomic number. So in this case, we're going to say 12 minus 6. So the mass number was 12. The atomic number was 6. So this gives us 6 neutrons. So this is where the 6 comes from right there. Now, our protons, remember, that's equal to your atomic number. So we just write that number down quite simply. And then if I ask you, well, I want you to calculate my atomic mass number, you're just going to take your protons plus your neutrons, and that's going to give you 12. Okay? It's that simple. It is that simple. Now, some keywords that I want you to be familiar with, which I kind of talked about them already. Protons, I already told you that it's equal to the atomic number, right? But I also told you that electrons equals the total number of protons in a neutral atom as well. And then your neutrons is equal to the atomic mass minus the atomic number. So what you have to keep in mind is that these three formulas are going to be important for you to know for your TEAS 7 exam, specifically for the chemistry part. So again, when you look at your protons, electrons, and neutrons, they all represent different things. Again, your protons, electrons, and atomic number, okay? They all represent the same number. So P, I had said pen earlier, but I meant P like a sweet pea. So your protons, electrons, and atomic number, okay, represent the same number. And then when you look at your neutrons, it's the mass number minus the atomic number. Now, take a look at this next example here. We've got sodium. So let's do a calculation with sodium. So on your chart here, you see that sodium has an atomic mass number of 22.99. Well, remember, we're gonna actually round it off to 23. So you'll get 23 for your atomic mass number. That's why we wrote it in here, okay? So 23 is your atomic mass number. The atomic number, this 11, that is also the same thing as your protons and your electrons. So there we have it 3 different times: protons, electrons, and the atomic number. Now, what you have to do to get your neutrons, you have to subtract those two numbers, your atomic mass number minus your atomic number. So basically, these two numbers here, we're going to subtract. So 23 minus 11 gives us 12 neutrons. It's that simple. Let's do another example here for carbon, okay? I know we've talked about these elements before, but again, I want to make sure that you guys got a great understanding of how all this works. So again, if you look at the atomic number, let's look at it. Right here, the one that I'm circling, that atomic number is 6. So guess what? Protons are going to also be equal to 6, and my electrons are going to also be equal to 6. Now, you see that 12.01? That's your mass number, but all we're going to write down is 12. Remember, we round off our atomic mass number to the nearest whole number, and that's where we get the 12 from. Now, to get our neutrons, we're going to take our atomic mass number and subtract it from our atomic number. So 12 minus 6 gives us 6 for our neutrons. So 12 minus 6 gives us 6 neutrons. This next one is on you for oxygen. So I'll give you a moment to complete this one for oxygen. I want you to tell me in the chat box what you think the answers are for this next example for oxygen. So if you are able to hear me, make sure that you all are able to participate and tell me what you think the atomic number for oxygen is in this example. If you said 16, you are incorrect. Why? Because 16 is the atomic mass number. What is the atomic number? Oops. Sorry, guys. I was on a mission. There we go. Yes, the atomic number is 8. That is correct. 8 is correct. All right, what is the atomic mass number? If you said 16, you are correct. And now, how do we get our protons, electrons? Remember, the atomic number was 8, therefore our protons and our electrons are also 8. Now, for our neutrons, all we're going to do is subtract the atomic mass number minus the atomic number. So 16 minus 8 gives us 8. And that is our atomic calculations for oxygen. All right, let's move to the next example here. Understanding isotopes. Now, isotopes are not difficult to comprehend, but what I can tell you is that if you do not get to understand isotopes, you're going to have a hard way to go when it relates to some of the information that you're going to have to know for your TEAS exam, okay? So for your isotopes, isotopes means it's atoms of the same element with the same number of protons, but different numbers of neutrons. That is what an isotope is. So what you're going to see at the very bottom of your screen here is an example of carbon-12 and carbon-14, okay? Carbon-12 and carbon-14. So right here for carbon-12, you've got 6 protons and 6 neutrons, okay? 6 protons and 6 neutrons. Carbon-14 has 6 protons and 8 neutrons. Now, something else I want you guys to kind of keep in mind here. And I don't know if you all can see this. On my screen, it looks like it's a dark box covering up the bottom half of this. So let me see if I can kind of get rid of that. I don't think I can. Okay. I may have gotten rid of it. Let's see. We're going to find out soon. And there is a delay, so just keep in mind there is a delay. Okay. Okay, so now if we take a look, okay, at my box down here, again, I'm not sure if you all can see it. If you can see it, give me a thumbs up. If you can see the box below, give me a thumbs up. Because I want to make sure. Because on my end, I can still see, it's like the box is grayed out at the very bottom. Let's see here. Okay. So now what we're going to do, we're going to keep it moving. Okay. But what I also want you all to keep in mind is that if you look at these 3 examples here of carbon-12, carbon-13, carbon-14, what you will notice is that they all have the same number of protons. But how are they different is the neutrons because of the mass number. So if we were to subtract in the first example of carbon-12, 12 minus 6 from the protons, we would get 6 neutrons. If we subtract 13 minus 6 for carbon-13, we get 7 neutrons. And then we do the last one, carbon-14, we would say 14 minus 6, and we get 8. Okay, so for this next example right here, we've got the isotope calculations for hydrogen 1, hydrogen 2, and hydrogen 3. Now, of course, you would need access to your periodic table, but this is where I'm going to let you guys actually do this on your own, okay? So you can actually fill this part in and you can put your answers down in the chat box and then I can tell you if you are correct or in the comment section below. And then that way we will be able to go back and see if you got the correct answer. And if you do, congratulations. I'll make sure to respond to your questions at the end. Here's another example with lithium. Suppose I gave you lithium 6 and lithium 7. Now, this is just a section of your chart, okay, right here from the periodic table. But now, if you remember what I said before, isotopes have different mass numbers, which means they'll still have the same atomic number for each of them, which means they'll have the same protons, but the neutrons will vary based upon their mass numbers. So in this first example here for lithium 6, if I told you that the protons is 3, you know you're just looking at the atomic number. So for both of them, that is the number 3. Now to get your neutrons, just subtract the 6 minus the 3, and you get 3 neutrons. Same thing for lithium 7. You're going to say 7 minus 3, and you end up with 4 neutrons, okay? It is that simple. It is that simple. Now, before we close out, I'm going to ask you guys a couple of questions here. This is a little short atomic quiz to see if you guys were actually paying attention to some of the information that we were talking about as it relates to the atom. So for this first question, this is the type of questions you will see on your T7 exam. And it says, which of the following statements is correct about an atom? With an atomic number of 12 and a mass number of 25. Okay, so what you got to keep in mind is that the atomic number 12 represents what? To help you do process of elimination, the atomic number of 12 also equals protons. So you can look at between A and C. Letters B and D aren't it because the protons are 13. Now, the other thing that we know is that the number of electrons is also 12. So that means if my electrons is also 12, that means we can automatically discount letter C and know that the answer could potentially be letter A. But let's go a step further. Let's go ahead and subtract 25 minus 12, and we get 13. 13 is equal to the neutrons. So the correct answer is A. A has 13 neutrons, but so does letter D, but you know that letter A has 12 protons, 12 electrons, and 13 neutrons. Whoops. All right, guys. So as we close out our lesson today, I want you guys to go back and look at what we've done. Again, I'm going to be giving you all small snippets of information that you would want to know for your TEAS exam. So I don't want these videos to be too long. I just want to give you all a snippet of what you can expect for your TEAS exam so that you'll know how to approach these questions whenever you take them. Also, let me know when you are taking the TEAS exam. Comment below so that I'll know when you are taking it and what we can anticipate in terms of things that you'll need to know over the next couple of weeks as we go through each of these lessons for your exam. All right, guys. Thank you all so much for joining me today, and I look forward to seeing you guys again for our next video on what to expect for the TEAS exam. Have a good one.